Hey everyone, this is Mayur. Welcome to ML Works. In this video, we'll be talking about RoBERTa model and we'll understand MLM, which is mass language modeling technique, and also will perform certain operations using Hugging Face libraries. Okay, now coming to RoBERTa model, it is an extension of a BERT model. It is a robustly optimized BERT, which is basically again a transformer model, which is trained on a large corpus of English text in a self-supervised manner. So when we say self-supervised manner, it means that we don't have a data set with features and target. Okay, we just train on a raw data set of text, and during the training process, we create features and labels. Now coming to MLM, okay, MLM is what helps in creating the target and features. MLM is nothing but masked language modeling. Consider you have an input sequence. The cat is eating some food. Some of the words in this particular sentence will be masked and used as targets during the training process. Okay, so in this case, in this particular model, there are 15% of the words in the input are randomly masked, and the model is trying to predict those masked words during training process. Okay, and it is quite different from autoregressive model like GPT, because in GPT model what we do is it is a next word prediction. Okay, so what will happen is in GPT model the cat is eating some dash. Okay, it will try to predict the word last word. Okay, it tries to predict the last word or the next word prediction. It is unlike where we, in this case, we predict a certain word in between a sentence. Okay, so that's how it differs from autoregressive model like GPT. And by the end of what training of a RoBERTa model, what we'll find is we'll get the internal representation of the whole English corpus, and which could be used for downstream tasks like test classification or question answering kind of tasks. So there is something called as RoBERTa based Squad 2 model. Squad 2 is a data set which is similar to a question answering kind of a data set, or a pair of question answers will be used on which the model is trained on. And we'll also look at that in Hugging Face library. Yep. So with that, what we'll do is we'll go to this particular library transformers, and we'll import the pipeline. And here, if you see in the pipeline, we are passing fill mask. Okay, so here this is similar to this image what we have. The cat is masked some food, and we are using the base model of RoBERTa, and the input is hello I am dash model. Okay, here is a masked word. Okay, we want to fill this masked word here using RoBERTa based trained model. So when I run this particular cell, so it will give us a bunch of output. Okay, the token is male. I am a male model, I am a female model, I am a professional model, I am a fashion model, I am a Russian model. So if you look at the score, okay, so there are like percentage. Okay, what it could be, the percentage probability for each of these particular token string. It is 0.33%, 0.04%, 0.04%, 0.0403%. Similarly, so the highest probability is given to male model. So this is using the base model of RoBERTa. Okay, so once you train a base model, you will also have something called as internal representation of these model, which can be used for downstream task. So in this case, as I mentioned here, RoBERTa base Squad 2, it is trained on question answer pairs. Okay, so we'll again load a model, RoBERTa base Squad 2 model, and will give question, and will also give the context from which it has to pick the answer from. For example, why is model conversion important? Okay, this is the context for this particular question. The option to convert models between farm and transformers gives freedom to the user and let people easily switch between frameworks. So the answer here is why it is important, because it gives the freedom to the user to switch between the frameworks. That is the answer for this particular question, why it is important. So this uses RoBERTa base Squad 2. Let us just execute this. And if we look at the answer here, gives freedom to the user. So it has picked this answer from this particular context. Okay, it has giving the start and end of this particular character start. Okay, character end. Okay, so that is there, and this is the confidence score. We can turn it as confidence score of 0.21. Now we'll give passing some other example. Okay, here we have transformer is backed by three popular deep learning libraries. These three libraries with seamless integration between them. It is straightforward to train your models with one before loading them for inference with the other. Okay, the question is which deep learning libraries back transformers? So the context that was given is this two sentences. Now when we run this particular cell, so we can see the answer is JAX, PyTorch and TensorFlow. These are the libraries that is backing transformer. Okay, and the confidence score is 0.94%. Okay, so in this video, what we have seen till now is we looked at RoBERTa based model which uses MLM, okay, mass language modeling, where you train a model based by masking some of the inputs or some of the tokens and train a model. And once you train a model, it will generate the internal representation of the English corpus, and that internal representation can be used for downstream tasks. And in this case, here there is another model called as Squad 2 model, RoBERTa based Squad 2, which uses Squad 2 data set, which is nothing but a question answer pairs. Okay. Now, first what we did is we just used the RoBERTa based model and tried to fill the mask here, and we learned how does that happen. Okay, it will give a bunch of options for every input, and then we did something called as RoBERTa based Squad 2, and we tried to generate answers from questions and context. So here we pass the question along with the context, and then it tries to generate the answer from out of these two. Similarly, in this example also we have the transformer based context and then corresponding question here, and we try to generate the answer from these two combination. So I hope you have learned something with respect to RoBERTa model and masked language modeling. And with that, I'll be concluding this video. Thank you so much.